Okay, here we go. If we have A times B is equal to 0, then what's A gotta be? Is there a requirement that A has to be 0? Nope. Could B be 0 instead? Yeah. Could A be 0 and B be something else? Yeah. What can you say for sure, though? One of them has to be 0. Could both of them be 0? So Rob probably should say at least one of them has to be 0, right? If I just say one of them has to be 0, that implies the other one can't be 0. Okay, so at least one of them has to be 0. All right, good enough. We've established that either this has to be 0, if that's 0, then I'm good, or that has to be 0, or both of them. All right, so can you get an equation answer, sorry, a solution to the equation such that neither A nor B is 0? So in other words, can they be two other things that are not 0? Is there any way to make it equal 0 without having a 0 in it? Nope. Nope. Not when you're multiplying. That's a good answer. If you're multiplying, you have to have a 0 to make a 0. Okay? All right. I mean, it's not like with adding, you can go like this and make a 0. But with multiplying, one of them has to be a 0. All right, the zero product property basically is a big, long, scary-looking thing, but we got to get used to reading these things. For all real numbers, A and B, which means this doesn't work for imaginaries, if AB equals 0, so in other words, if you get two things times together equaling 0, then A equals 0, B equals 0, or both A and B equals 0. Good, that's a property. All right, in other words, we don't need in other words again, we've already said that a few times. And here's the key, you have to have just 0 on the other side. If this is AB equals 7, this does not work. It has to equal 0 to make it the zero product property. All right, if you were just going to solve this first equation for x, do you agree I'd have to divide by 15? And this presents us with our first problem where either you know what to do or you don't. What do you think the answer to that is? 0. A lot of people think that that's not allowed. It is allowed. What's not allowed is this. You can't have something divided by 0. And the way I like to have you think about it is if it's cookies. If you have 0 cookies divided amongst 15 people, then what do each of them get? 0. And it makes sense, right? What if you have 15 cookies and you divide it amongst 0 people? There's no people. There's no way to get... Excuse me. This one, you can't do it. You can't divide amongst 0 people. That doesn't make sense. I guess, in a way, you could argue that you still have 15 cookies. But the point is, you can't have a 0 on the bottom. Okay? So you can have a 0 on the top. So this is okay, and the answer is just 0. Done. Now, why is this about the zero product property? Because, see, I had two things multiplied together to equal 0. Do you remember just a second ago we said that either this one has to be 0 or that one has to be 0? Well, what if one of them already isn't 0? The other one has to be 0, right? Logically. Okay, so this one has to be 0, just from thinking it through. You just use the rules of solving equations. It works too. X equals 0 over 15, which is 0. All right, next one. Do you get how this and this being multiplied together and equaling 0 is the same thing? It's two things multiplied equaling 0. So either this one's got to be 0 or this one's got to be 0. How would I make that one 0? If x is negative 6. And how would I make this one 0? If x was 3. There's two answers for this. That means if I multiplied this puppy out, you'd recognize it looks like a more normal problem. It would be x squared, and then the outside and the inside go together, make 3x, and the last make minus 18. That if I put in 3 into that equation, it would make it equal 0. If I put in negative 6 into this equation, it would make it equal 0. Okay, so it's just easier to see when it's written like this. My two answers are that and that. Now, next thing I want to get to is, okay, why is there two answers? One of the things that I think is under-taught in the past, and I know I taught middle school for a long time and I didn't ever teach this, but it's really powerful, is if you have an equation, no matter what kind of an equation, like a 2x squared plus 3x minus 5 is equal to x to the fourth plus 3x plus 7, that would be a real pain in the butt to try to solve. But there is a really simple way to solve it with graphing. If you graph both sides, y equals this, and y equals this, and you see where they cross. Let's just do a simple one that would be easy to type into the calculator, like this. I know you know what the answer is. Don't overthink this. What's the answer? X equals 2. Let's graph the left side, graph the right side, see where they cross, and I think you're going to learn something. Graph the left side, graph the right side, see where they cross. Okay, so it's x equals, or no, sorry, y equals x plus 5. So x, hear that, x plus 5. And y equals 7. I hit graph. Does it look like my two lines cross? Yes, it does. And how do I know that the answer is 2? Because at the spot where they touch, what is x equal to? 2. Now, what if you weren't sure? What if it's hard to read this? Or what if the next problem was way harder and the answer was like 2.679? How would you find out where they're crossing? There is a special way to do that, and I want you to become a ninja with your calculator this year. Like, I know how to graph this. I know how to find where they cross. This is easy. I know how to use this feature and that feature. There's like 75 features I'm going to teach you this year. All right, grab your graphing calculator, hit second. Calculate. It's right above trace. And which of these looks like the thing we want? Intersect. Choose the fifth one down, intersect. And now it asks you a question. It says first curve. I wish it just said first line. Sometimes lines are curves, but sometimes they aren't. They always say first curve. It must be some high-level math thing. I don't know. Anyway, the first curve is just the first line. Is my little spider on one of the lines? Yes. So you hit enter. Now the little spider jumped. I don't know if you saw it jump, but now it's on the straight line there, or the horizontal line. And it asks for the second curve. It's basically asking you for the two lines that are crossing. Because see, sometimes you can have 10 lines all crossing on a graph. And if you want to know this line and this line, and you have to tell it about where they cross, then it'll tell you the spot you want. You know what I'm saying? If I had 10 lines all crossing on this thing, there'd be lots of intersections. So you have to tell it which line and which other line, and then where about, it says guess. Where about is the spot you want? Because see, this sometimes there's only two lines, but they cross in two different spots because one's a curve and one's a straight line. Last one you hit is enter, and then it says 2 comma 7, and which one of those is the answer, 2 or 7? 2, because we wanted x. Look back at the original problem. It's blue on the board there. It just has an x and it doesn't have a y in it. So I don't need the y, I need the x. So x equals 2 is my answer. And you knew that already. You knew it was going to be 2, right? All right. So now you can use the same technique to solve really complicated looking graphs or equations. Let's try one. Let's say we had 2x plus 5, parentheses x minus 4 equals x times 4 minus x. Graph the left side, graph the right side, see where they cross. Now this is a little tougher one because this is a curve. It's going to have two answers, two places that they cross, probably. Just making this one up out of nowhere to show you it'll work for anything. So, but that is fraught with danger too, because maybe this has no solution. It's possible. If the lines don't cross, there is no solution. All right, so I'm going to go to y equals. Cool. 2x plus 5 parentheses oopie parentheses x minus 4 minus 4 into parentheses, and then they go to the next line I make it x parentheses 4 minus x. That would have taken you a long time to solve by algebra, but if I just hit graph and I see where the two lines cross, awesome, they cross. They cross in two spots. A lot of people wouldn't notice that. You can see one spot where they cross on your screen. But just imagine if you could extend the graph out farther, it would cross in two spots. Now, how do I see down there where it's crossing? Yeah. If I go to zoom or I go to window, either way would work. I'm going to go to window and I want to see way lower. Is that an X thing or a Y thing to see way lower? It's a Y thing. So I'm going to change my Y min to, let's say, negative 100 or something. Okay. Ooh, I don't need 1,000, that's for sure. I hit the button by accident. There we go. Graph. There we go. See, it crosses twice. There's two answers. But can you see how that could really help you, like on the SAT test where they say solve this equation, and it's big and nasty and hairy, and all you have to do is know. You can use those calculators in the SAT test, yeah. And they would be expecting you to solve it the long way, but if you know how to do this, hey, you're just solving the problem in a different way that's legal. So, graph both sides, see where they cross. Okay. Well, if I wanted to know the answer, I would have to zoom in on these spots. I'll do one of them. Second, calculate, intersect. So I go to number 5, and it's asking me for the first curve. See my spiders on one of the lines. Then the second curve, it's spiders on the other line. Now this is the important part where it says guess. I got to go right next to the one I want. So let's say I want that one right there. There's two answers. Remember, there's that one and there's one down lower. I'm going to try that one. And there's my intersection. X is 3.21699. So there's my answer. If you were to take the time and plug in 3.21699 into this, and that, and that, and that, it would work. No, it would take forever. Okay, anyway, I was trying to show you something kind of, I think it's kind of cool, that you could solve equations by graphing both sides. Why am I showing you that? Because if I graph this side of the equation and this side of the equation and see where they cross, can you picture that it'd be a parabola? Because this is x squared, right? Once I multiply it out, that'd be an x squared thing. So that's a parabola. And what's y equals 0? That's a line that goes right across here, right in there. And where they cross would also be known as the x-intercepts. See if you can put this all together now. If where they cross is also known as the x-intercepts, then that's where, what's the intercept? Where y equals 0. See how y is equaling 0 here? If y equals 0, you have the x-intercepts. All right, so in this equation, I have y equaling 0. It's at the end here. And you set y equal to 0. That way you have the x-intercepts. And then you will get your answers. This one will have 3 answers. There's 3 things that would make it work. Why? Because when you graph it, it looks like this. It has 3 x-intercepts, places where y is 0. All right, so let's actually do this one. Would you please write this one down on your paper? It's the one I am circling in blacks. Write that one down. Then, if you really understand what's going on, you should be able to tell me the 3 answers. What do you have? The 3 answers? Okay. Old homework, last 10 minutes of class. All right, a lot of people get confused by this one. There's 3 parts. That's one. This is another one. And this is another one. Everybody gets the red part. What's the answer to the red one? 7. X equals 7. The green part's just a little harder because you have to say 4x plus 5 equals 0. And yes, you could do this in your head. The answer is a negative fraction, but I'm not sure what it is. So I go, just solve it the normal way. Set it equal to 0. Go minus 5, minus 5. 4x equals negative 5, and then x equals negative 5/4. There it is. It's a negative fraction. Just makes sense because you want this thing to end up multiplying in and making it 0 for the whole green thing. And the last one, the blue one, is a very simple answer. You just have to understand, how could I make that 0 if x was equal to 0? So that's another answer. So I got the blue answer, the green answer, and the red answer. I got 3 answers. If you graphed it, guess what would happen? The lines would touch 3 times. Once at 0, once at x was 7, and once at x equals negative 5/4. The calculator wouldn't have said 5/4, it would have said negative 1 and 1/4, negative 1.25. Yep. All right. If you were to do this one, the zero product property says that if something's being multiplied, that's a product, that this has to be 0, or this has to be 0, or both. You'd set this equal to 0, and this equal to 0. Oops. And I solve this side, and I get my 2 answers. That's all there is to it. Do you get what to do? Zero product property. I don't think it's that bad. All right. So let's kind of sum it up. When you have these graphs, remember they're x-intercepts. The things you are finding are x-intercepts because the x-intercept is where what? Y equals 0. So all your equations look like this. It's where y equals 0. That's because we're finding x-intercepts. And I got 2 answers for a lot of these because they're parabolas. And parabolas are going to touch twice, usually. Could a parabola only touch once, like that? Yes, it could. And then you'd end up with 2 answers, sort of, but only 1 answer, really. It would look like this. Do you get how that's sort of 2 5s, but it's sort of only 1 5? That's how it can be 2 answers, but only 1 answer. They're both the same. X equals 5 and x equals 5 are my 2 answers, but they're both the same. Okay. On these, first of all, I don't want you to forget what you learned yesterday, which is that this is in vertex form. So that has told me the vertex. What is the vertex on this? 3, negative 4. So if I'm graphing this thing, that's where I'd start. Over 3, down 4. Right there. And now it's a normal parabola. Look, it hasn't been flipped, it hasn't been stretched or anything. So it's just a normal parabola. Over 1 up 1, over 1 up 1, over 2 up 4, over 2 up 4, and there's my parabola. Done. Okay. Now, if I want to find the zeros, there they are. They're x-intercepts. Could I have done this with the zero product property? No. Thing's not set equal to 0, and it's not factored and everything. So that's why we have the graph paper here. Because if you graph them, you can get your answers by graphing, or you can get your answers by the thing we were doing before. The zero product property works great if it's set up like this. But if it's set up like this, it's better to graph it because it's all ready to graph. You've got the vertex. All right, this one. Could you graph it? Well, yeah. In fact, it already has it graphed for you. So what's the answer? Come on, look at it. 1 and 5. What does that mean? If I stick a 1 in here and here, it'll equal 0. And if I stick a 5 in, it'll also equal 0. I'll prove you with the 5 one. 5 squared is 25, minus 5 times 6 is 30, plus 5. What's 25 minus 30 plus 5? 0, which makes sense. Yep. It'll work with a 1 or it'll work with a 5 because these are the 2 answers, 1 and 5. Okay. I hope this is coming together for you. So, getting close to Thanksgiving. It's a lot closer to Halloween actually than Thanksgiving, but quit whining. All right, here you go.